I welcome Sai Praveen for this podcast. This is a podcast where I do with a data science who has demystified the holistic approach in understanding what intelligence is all about. You know, there are ways in which people have told machines can be programmed at the end of the day. Yes, they can be programmed, but they can never be attained with the full consciousness of being an entirely behavior of a human being. It's something huge. So now I'm trying to demystify what Sai Praveen. Sai Praveen is a data scientist at Data Semantics and also a community builder and a machine learning engineer at Omdena. You know, taking two roles, obviously, you need to have a girth of an warrior in order to achieve something like that, and thanks for Sai Praveen for this podcast. It's an amazing thing for me to, after reading his article in Medium and now doing a podcast with him, it's such an amazing thing. And thank you, Sai Praveen, for this chance to demystify what's intelligence through an holistic approach.
Yeah, thanks a lot, Visas, for the opportunity and very good evening for everyone.
And also introduce about yourself, Sai, so that
Yeah,
everybody will get to know what it is.
yes. Myself is Sai Praveen. I'm working as data scientist in data semantics. I do have around experience around 3.5 years, 6.5 years as of now in the field. I worked with computer vision, I worked with NLP, I worked with recommendation systems. Like you can say, like I'm much more to learn. Uh, like that. I mean, I've covered most of the fields which are in the deployment part and the production, and then I know what are the areas where AI is really successful and where AI is still yet to achieve that role. So once with Viswash, we can start and we can have a question session and understand much more about AI and about me and about what is the situation and where we can go ahead in the next for future days.
Thank you, Sai Praveen. Let's just begin with the questions then. So now, because last time when I actually read your article, I felt okay. It's a very holistic way of understanding what intelligence could have been through giving references to Vedas and all these, right? But I just want you to give me that one intuitive understanding of the difference between a processor, brain, and a computer vision system today, and how are they different from each other? That's what I really want to know.
Okay. When you say processor, brain, and a computer vision, processor is just a sequential model where we will give some set of rules. It will just follow them. So we have to say, if, when basically the inbuilt is because of the transistor achievement, that is a main building block of processing any information and calculating the data. That is a main inbuilt. After the transistor evolved into microchip, microcontroller, microprocessor, then we today we are using i5, i7, i10 is in process. Like it's just a programming way where it is actually doing the calculation, where electrons will flow from each other, where we're basically controlling the flow of electrons and making the machine to attain the state. So it's basically, we can say it's just a device which is storing the information, which is processing the information. But when you say brain, it is a very complicated uh, uh, model or structure. We don't know. Like we are to solve why how much the brain capacity evolves, right? We are probably we generally only use 8 to 9% of our brain in our day-to-day lives. And Einstein is the only guy who has so much of IQ and AQ, where he solved so many and which he discovered so many things in the field of physics and chemistry and in the nuclear physics, like that. So we had to know discover so many things about the brain. When you say computer vision in as a part of this part, computer vision is a way how the machines will see the world. When you say the world, it's a 3D image as for our eyes, right? uh, Whatever I'm capturing from my eyes, I'm processing them in my brain and understanding the difference between the objects, right? When in the childhood, people will teach A for apple, B for ball, like that. So the way the how much we see, we're capturing the difference between the colors and identifying the object, and then storing that information so that we are processing them later. Computer vision, we can say it's similar to a part of eye of humans. where it is understanding with the visualization, whatever it is seeing. Uh, the only difference between a brain and a normal computer vision is computer vision can only process the 2D images, but not a 3D world. But our brain processes 3D. So there is a one dimension difference, which makes a way more difference between the understanding of these two. Uh, well, I mean, since we can say in the when you compare, machine can be the basics, or later computer vision can be the second one, and the first one will always be the brain, because it do computer vision, it do NLP, it do recommendation systems, and it do I mean much more, like it learns itself. It learns, it processes images, voice, text, and it responds. So it's a combination of all these intelligence which we have today, which is only processed by single brain. When in the present AI, we have different algorithms for each specific task. If it is recommendation system or ranking algorithm, or we can say object detection, or a driverless car, which is how to track the roads and all. So it's a, we have a specific application for each task, but brain processes all the information at once and understands it and defines it and empower ourselves. So to achieve a state of a brain, it really takes so much time for AI to reach that level.
I just wanted to ask you, which is harder? Is it an language or is it vision which is harder today? Which is that one? Because you have worked on both. I think probably in future you might even regret this work which you have done and like, okay, I just want to do something else. But like, you have worked on these two, and which is the most toughest one? Is it the language or else is it the vision?
See, toughest one, I don't say anything is tougher, because if you have that passion to learn and understand things. But as per the industry standards, when you compare, computer vision has achieved much more than NLP in today's. After GPT-3 implementation, when we say sentiment creation and natural language generation, when generally NLP consists of three things: NLG, NLU, and NLP, processing, understanding, and generation, right? And now we are in the state of generation where computer vision is already making so many applications in VR and AR, where they created so many video games to where interacting video games where you can interact. For example, some can be in Japan, some can be in America, some can be US. They can play combinedly online game using VR and AR, where the information is transferring in very fast rate in live. So that is the stage where computer vision achieved. But still, NLP has very much more uh, product, very much more utilization in these areas, and there is more to go in terms of NLP. It is still in evolution, which is very critical or very difficult for me to understand is NLP. I should definitely say that, because there are so many, even today, there are so many companies which evolve around document processing, OCR, analyzation of documents. After analyzation, segmentation of the documents, and then searching the specific documents from the database. So document retrieval or the information gathering. After, if I have a huge amount of libraries, with, for example, around 10,000 books with me, I want to refer a specific topic which is related to the. If I want to go and search into library, I have to go there. I have to know the index and then open the book. Instead of that, if I have a specific search bar which will do the processing and which will identify those books and say this is the relevant topic and this is the relevant book for me to understand those complexity in the books. The machine should understand the book and the knowledge in it. So generally what happens is when you say NLP, it converts the words or sentences into a specific vectors, and from the vectors it defines the dimensions of it. Basically, it don't understand what the meaning of a word. It's just representing a word in form of a vector. In terms of computer vision, that is not the case. In computer vision, you may, I mean, this all evolved because of RGB. rays. We are using smartphones, television, mobile phones, all this. Because of these colors have they have their own unique code. It will easily identify and gather them. It can the machine can easily process, because all the supporting softwares or the supporting color algorithms are already available. But in terms of NLP, we can say like there are so many languages, so many slangs, and so many humor, right? Sometimes we talk with humor. So machines won't be, as of in present scenario, machines won't be able to understand those things. So NLP is much more challenging for me than computer vision.
Yeah, there is way in which
Mute, mute.
yeah, yeah. Shit.
Yeah,
Yeah, there are a lot of ways in which research has taken twists and turns here and there. There has been uh, research which has seen tremendous amount of accuracies. There are research and algorithms which have been seeing tremendous amount of losses also. A lot of setbacks in this industry also. Whether it's not like okay, field of bioinformatics had a lot and lot of failures initially. Even this field also has seen lot and lot of failures. But what do you feel about the key research that took this community into this amazing workflow of having this buzzword of deep learning, and everybody is enthusiastic about deep learning, whether it's a biologist, whether it's a physician, everybody is behind deep learning algorithm at the end of the day. What actually took this thing into the workflow of the community?
yeah. Basically, the main difference between machine learning and the deep learning is the number of neurons it computes when it is processing the data. In machine learning, you won't have a backward propagation. Basically, it means like you can, in simple manner, I can say, if I am cooking something, I may have added salt or sugar, so much more, and I got it wrong taste. So later, when I'm doing the same thing, I will remember what mistake I did, and I will try to correct it. So this process of correction is available in deep learning, which is similarly they say it's backward propagation, where they understand from their mistakes and try to reduce the loss or improve the accuracy. But in machine learning, it will also do. It is like we can say it don't understand, or I mean it can't correct itself. We have to be there and correct it. For there may be some, if I'm getting tuition from for my cooking, someone should be there and teach me, you did this thing wrong, you did that thing wrong, you need to correct it. So if we do the correction, it will perform well, but it cannot understand the mistake and try to auto correct itself. That is the only difference between ML and DL. But when the output of ML and DL, the applications, when you can go, ML has in most of the times in industry, most of the times we use ML. Deep learning is only for a specific complex problems, not for every time. We can say like in simple ways, like a job offering for a degree guy and a job offering for a IIT guy. So there is so much difference, right? The amount of work they handle, it is like ML will do normal tasks, but deep learning should have much more complexity to apply. And I cannot ask a deep learning to simply use for a normal classification model or normal regression model or normal random forest, whatever. Like it depends on the task. We have to choose the algorithm. Deep learning has much more craze nowadays, but it generally most of the times fails because they misidentify the problem and apply a wrong algorithm on top of that.
Yeah, speaking of the failures and what actually took, it's an broad way of understanding what really led this community into this kind of an workflow which we are seeing today. People are coming out with open source frameworks and toolkits which are available today. I just wanted to ask you this one question because our research basically moves more towards building a brain on a burning box, that is an CPU or an GPU at the end of the day. Let it be a card which has been cased out with the metal, and yeah, that's what our research is. Our day-to-day work, the bread and butter. That's what we are building for. I just wanted to ask you this one question: will a processor, a microcontroller, or anything that we are wishing to build, neuromorphic chips are there, neuromorphic computing is coming into the picture. I just want to
Yeah.
ask you this one question: can all these hardware sum up together and one day be the brain of tomorrow? Literally the brain of tomorrow. How it start working. I am not saying whether it's an organic matter, which the CMOS chip we are trying to build, but at the end of the day, it needs to behave as good as a brain. Human brain, blue brain projects, lot of come out, but like, can it really be the new brain? And what is that actual ingredient that is required for building that brain onto this burning box?
Yeah, okay. If I mean similar, I mean the question which you're referring to is AGI, artificial general
Yes,
intelligence,
yes.
where it is similar to brain. What are the process we're doing? You should understand those things and all. Basically, AGI is still in research. It is not at, as per my knowledge, it is not at uh, configured, or we didn't crack it till now. It is definitely a possibility that we will achieve AGI in all the sectors where humans can have much more easier life, rather than the people in the eighth gen, or older on 80s 90s and nowadays. I mean, our future population of the humanity will explore much more related to the AGI. As per the present situation, it is still in processing, because the support for AGI, the basic hardware, is still missing. What are the processor GPUs we are using now? The present hardware won't support that kind of capability to make a mission to do a multi-processing in terms of AGI. So it's achievable, but there is some difference when you say comparing when it can be a brain or not. Brain only, when I say brain, I mean it is only one some part of the brain it can achieve by AGI, like processing the information and responding back. It can be image, it can be text, or it can be voice, or it can be any dance, anything. I mean, if it is an action, it will respond with a reaction. But to have though, but brain will have much more things like feelings, sadness, hunger, and pain. So those type of feelings, I mean, uh, won't be able to achieve by AGI.
Living all these kind of feelings that we want to install on a system, it's impossible to some extent. Yeah, we can fake it, but we can never make it as good as a human being. We can fake it
Yeah,
somehow, we can fake it. you know there is an Gusto thing which actually came out in 2001. He actually passed the Turing test. you know there are ways in which we are trying to fake it, and we are told, okay, a chatbot actually passed the Turing test. All these, but like, you know I just wanted to ask you that one question where, yes, there is a first time for all the technologies which you have seen. GPT-1 came in and we thought, okay, this is the new boom in the technology, and GPT-3 is already being spread to the world. I also subscribed for it. I'm also just joining inside the Slack channel and all these. Things are working on for us. It's an open source software now at the end of the day, which will be in the hands of all of us in the future. But I just want to ask you this one question: do you still remember your first code in the work, actually, when you're working on deep learning, and how did you work on it, and what was the process of learning all about to you?
okay. When I first started my career, I was an intern which doing internship at KPT. Basically, it is a company subsidiary of Tesla, which we are doing building a prototype stimulation for the self-driving cars. That's my first project, which I did something related to embedded C and then Python and then processing computer vision, understanding how a engine will get the response from the sensors. I mean, it depends on the sensors, heat or the environment, how it will get response. We have to code that and make the driving, make the car to drive on the lane with following the traffic rules and reach the end. And we are checking the identities, like what is the fastness it is doing, whether it's rash or whether it's safety, whether passengers and all that. I mean, that is a stimulation we need to do. It's not a real thing. The time it is for me, it's like a you can say I'm very excited and very there's some fear too whether I can achieve it or not. Like it's the first time in the field. Like uh, I didn't slept for 3 to 4 days to understand because we did the training processing, but sometimes it is failing because there is a U-turns where so much way and the car has stopped. It is not moving further. Like I mean, that is a facing and I mean where it is not aligning with the lanes of the road, and sometimes lanes won't be available in the road, so it is missing and it is moving. It is not going on the road. It is going to the woods and all. So it's a I took around 3 to 4 nights, day and night, to fix them, to understand them, and at last I did it. It's very it's very enjoyable moment for me, which made me to which really encouraged me to be here now. Like that passion, right? The approach which I taken, like the achievement and all, it drives me till today. And now I am still so much more to drive myself to understand much more.
Do you still remember that the way which you had coded it? Any code which you still remember today?
Yes, I do remember the codes which I do.
In which language?
Uh, it will be Python. I'm from Python background,
Yeah.
specifically in the Python, where the specific code which I still remember is uh, before sending the data to the algorithms. We used a deep learning LXNet at the time. There's a popular one. The main identification which I did was whatever the data it is coming from the sensors, whether to go move forward from the camera angles and all. My main drawback at the time because is when it late nights, when the image is not clear, the machine is missing the data and it is not driving properly. And when the daylight is different, when the daylight, when the rainy, and when the lanes are not there in the road, but this is a data which the machine didn't know. I mean, this environment, and this kind of environment, it never faced because the data which we already trained has everything clear, very precise and very neat. There is no obstacle for the car. It just follows the road because everything is very good. But in real world, that is not the case. So the specific the code which I written for to correct it, it took me so much time. And what exactly I did was instead of me creating a existing creating LXNet, I searched in the GitHub and many more Slack channels. I introduced it with the people who already in the phase, and they have given me a model which was already trained. Then I used a transfer learning approach and then make adjustment with my environment. That is when I got succeeded.
That's how it is. That's how it is. First time when we are actually doing anything, nothing comes in our hand. Even if you have solved this problem statement 100 times, if the data is not clean, if the data is not according to your algorithm, data needs to be clean and also precise for it. Real time processing is a different story at the end of the day. But when you're training, it needs to be proper. It needs to be annotated in a good fashion. Linux come handy when you are annotating at the end of the day. You just select it all and just start naming it. It starts working, kind of thing. I just wanted to ask you this one question: how has computer changed the field of robotics or computer vision today? What's that robustness that you're seeing in the computer these days compared to the earlier days of what we had, the Pentium, Celeron, the Platinum processor chipsets? I worked in Celeron because, yeah, I was fascinated about computers since my young age. And yeah, I have worked on Pentiums, I have worked on i3, i5, i7. I'm also getting an i9 now. So yeah, yeah, that's how it is. How has
Uh,
computer
the
changed?
Yeah, the answer is in your question itself because you only change it from Pentium to i7. So basically, what exactly is changing is because it's speed and accuracy, the multitasking,
No,
much more
earlier
things.
when I asked the hardware engineers, they used to wait for 6 months in order to get the new upgraded ones. You know, I have heard it in not a TED talk, but yeah, in some talk, he had told that if I wanted a new thing to be built on my computer, I just am supposed to wait for another month or two or 6 months or so in order to get a new thing which can come up. But today it's not the same.
Yeah.
Clocks change, but not the same thing. And also there is some speculation where deep learning researchers have they themselves have told, if you would have had asked me 10 years what computer can do, I would have laughed at you what it is doing today. If you have said me the same, it can be done 10 years before, I would have laughed at you. That's what the approach was. What's the robustness that you have seen
Uh,
today?
okay. See, the first was here application was built in 1989, and with Selenium or Pentium processors, which now we are using i7 and i9. At that time itself, they already had defined the algorithms. I mean, as of now, the society knows AI, ML, algorithms, processing. I mean, they get to know these things. But the research which you are using now, whatever the algorithms are behind the TensorFlow, and Manhattan distance, Eleusinian distance, or creating the random forest classifications, or creating the tree number of nodes, these max which is behind, which is driving the calculations backend are not arrived are not derived now. It was derived before the processor has came into place. Many mathematicians already submitted so many proposals related to computer vision and AI and NLP much more before than the nowadays systems are doing now. The main difference which you got is like at that time they have the knowledge but they don't have a supporting hardware. Since they don't have a supporting platform or the hardware, they cannot prove it. It is like they're just waiting for opportunity to showcase their task. So till then they just publish their papers and the papers never went to the real world. Let's know they perished later on because of Google when the Google released the first TensorFlow. Initially the TensorFlow had didn't realize it when they starting the project. It is for AI. I mean, if you have seen the team leader of TensorFlow group, he would say
Jeff
in
Dean.
his interview. Yes, yes. Sorry, I am very poor at remembering names. He said that is not his goal of the team. Basically, they want to invent something related to the sensors for the mobiles. After releasing Android and all, they want to make it much more clear and easy for where with the hand gestures and all. The if I say like this, the volume should go up. If I should pass based on the with tapping with gestures and all, the camera on the phone should capture them and should make much more robust OS for the Android. That's how it got started. And later on, when they implemented those things, they understood it has so much capabilities. And then later on, they did the first TensorFlow, and that's how the AI or the ML, whatever you are seeing now, it got started. Later again, Facebook introduced PyTorch, and PyTorch is different from the TensorFlow in better ways. Sometimes we use TensorFlow, sometimes we use PyTorch related to the specific task, which software or hardware we have and the resources we can compute. Based on that, we can differentiate which one we should choose. So like that. So in the processor or Pentium or whatever, the research which we are using now is much more older than the more older than my age.
Yeah, my age is also not the same. It's pretty much older. Marvin Minsky. Yeah, I should actually come up with this. Marvin Minsky started with this trend of an AI and MIT. That's how this
Yeah.
trend of AI started. But thanks for actually giving me that chance to remember all these people. I also think probably Rajat Monga is one of the person who actually is behind the workflow of the TensorFlow in Google,
Yes. Yes. Yes.
including Jeff Dean, who has also
Yeah.
been the part of the Google. A
Part of the
lot
team.
of hands of Indians have gone and a lot of hands of many people have gone, and yeah, it's a proud thing for us. Let's just move on. Yeah, fine. There are layers of abstraction in computer architecture and parallelism. What's that influence that you have seen by implementing all these techniques today in computing of computer vision tasks that you're seeing today? There's GPUs, TPUs today, but yeah, how are these essential elements today on getting the research to the place what it is today?
Basically, when you say computing and all, so in a simple manner, I can say that I mean, based on my physical body, I have my restrictions to do how much of workout I can do, right? So everybody, I mean, every person has their own set of stamina to process them. After that, what they will say, I can't do that. I need sleep, something. So in the same way, like even the software of the computing part, it needs the support from the hardware. It cannot say that I can if I ask number Pentium to if I load any Assassin's Creed game in it. It takes so much time to process. It is not that it cannot do, but the load it should take is much more higher than its capability. So because of these GPU, TPUs, and the structure, these kind of environment is now solvable so that machines can compute parallelly or sequentially based on the problem and give the results in a much faster and better way. I mean, once it is delayed, normal process, once it is delayed, sometimes the data will be misrepresented because there is a lag in the data transfer within the universal buses. The data will have a misleading communication and which lead to a wrong information if the process goes very slow. Since now the process and the transformation of the data is very fast, so there won't be any loss in the transformation and we will get accurate results.
Yeah, yeah, we have talked a lot on all these things of compute now. So let's just get into the architecture what we are thinking about. Can we build a neural network architecture to reason what it has learned from whatever we have trained? There are ways in which AGI is in a factor today. AGI needs a huge set of neural networks built on it. What's that one thing that we are waiting in order to give that power of reasoning for a neural network?
See, Google already initiated uh, a research. It already implemented the first beta version of it, where it and identifies why a mission. They want to demystify from the from the black box to where there is a reason why the mission choosing these specific features and all. Uh, and as per to make achieve AGI, the present algorithms, as I said earlier, they are defined for a specific task or computer vision or document classification or the OCR, or you can say extracting the data or identifying the objects, or instead of identifying, we can say drones, where area surveillance, and like this, right? Or we can say normal mission which will clean mop and clean the floor. So which has a specific task. If I say AGI should perform all these tasks itself. So it's a multi combination of NLP, NLG recommendation systems, everything in one go. So to achieve that, we still need to have that kind of support from the hardware and also the software to communicate with each other and achieve the tasks. As for the present software, we are only using the classical versions of the computer, which won't be able to give us the specific uh, opportunity for us to drive them to AGI. And the best option which available is quantum computing, where the hardware is really supportable for this kind of task and which can be achievable.
There is an edge deployment that we are seeing these days. Edge computing is in a new boom. It's a new trend. It's going to be the new compute tomorrow. I think so,
Yeah,
because of course there is an lag in which 5G technology has shown in order to come to the world, because it's not been completely proven to be the fastest means of communication that a man has ever built. But there are pros and cons in it also,
yeah.
environmental issues, lot of things. What do you feel about the benchmark these days, computer benchmarks that you have been seeing throughout? You said you have 6.5 years of experience. Probably I've seen lot of benchmarks which are going on. We never had an i9 which was to be dreamt about in order to get one day. We all saw all these kind of things which just rolled in and out of the technology. So what do you feel about the benchmarks these days?
Yeah, benchmarks are a way to identify ourselves where we achieved and what is left to achieve. Right. So benchmark says, for example, if I have traveled around 10 kilometers, the other person had the chance to beat me, right? So initially, when computer vision has started, we only use precision, recall, that matrix, true positive, true negative, false positive. I mean, we have very limited to basically to evaluate a model. But nowadays there are so many uh, cal- classes or so many calculations to basically understand where the mission model, deep learning model stands. So basically these benchmarks, what exactly do is it will convey the information whether it is better than the other models which are already available in the market. And the next thing is what is the another best way to beat this model, right? So they won't be, and if I achieve 100%, there will always be a space for 10,000, right? So that space gap, right? So we can know where we stand now and where what we can achieve tomorrow.
Yeah, since we all are EC folks, we just have this one doubt on where's the DSP being used in computer vision and NLP, digital signal processing. Where does it fit in today's world? It's a whole new set of algorithms which has been developed years ago. Probably a Stone Age kind of a thing which we are thinking about. Like where does all these techniques fit in this current era of computer vision and NLP,
Yeah,
deep
yeah.
learning, and all these?
So digital signal processing comes in terms of networking, and without transferring the data from one place to another place, can be between the a UCB board in the laptop from one corner to other corner, or from the controller to the processor, caching memory and all, or we can say when the transforming data from mobile phone to the tower and from the other communication, or that the way we are communicating now via Zoom, basically whatever the information you're getting it, right? So that signal, basically that digital information should be processed, so it will transfer the information from one place to another, right? So in the back end, these are always exist. On the top of it, we can add NLP, or you can add computer vision, you can add so many graphics, whatever you do. Basically, the main fundamentality of processing a signal is always the same. Maybe we never know, we will never use them because they're already built. So there is no research. I mean, there is no point of again going back to DSPs now. Instead of we should go move forward.
Yeah, what's the thrill in building such kind of a system? Computer vision, NLP, deep learning systems to just make the decision. We are actually building a machine which can make decision in favor of us or for us. Not in favor of us, and for us. If you are
Yeah.
gambling, yes, it should be in your favor. If you're not gambling here, you're just getting to know the insights of what might can happen. What's the thrill in building all these kind of systems? Actually, programming precisely according to your work which we have actually witnessed.
Yeah, it's thrilling sometimes when it works, and it will be a nightmare when it won't, right? So, to solve these kind of problems and all, basically the main thing which drives me a lot is I always keep my thinking empty, and always prefer to say I don't know much thing. There's so much more to learn, right? So when we know that this is a part which drives to achieve our target. So because if the pot which I have in my hand is already filled, I cannot keep much more water in it, right? So I have to always make my pot empty, or I always make my pot bigger so that I can learn more. uh, this is what are the techniques. Even the present data scientists who are dealing with many tasks may don't know the newest technologies, because every day there is a new single paper which is appearing with a new technique every single day in the entire world, right? So the to solve the problems, the only thing which needs in this area is you have to make yourself uh, grounded, and you have to be very simple and understand each day and learn every day what is going on in the market, and far you are understanding the changes and why the change is made. Changes will come with new models. For example, in Inception, there are three types. Inception models of the three types of sometimes they use the filters one by one, three by three, five by five, but they will make something changes with the activation functions and derive some much more, right? So why these changes are required? Why these changes are made in the architecture of the model? If you know that, if you learn in that kind of way, you will definitely achieve your target. If you don't know, then I will get stuck at my work, and I hope I should be. I mean, it will be a bad call from my side.
So yeah, speaking of the bad calls, there is ways in which even if we run 100 times the same program with the same data set, we are not supposed to expect the same result from a computer. Computer throws out different numbers at the end of the day after it number crunches. It's the same data, it's the same thing which we are given, but there are a lot and lot of speculations on this because human have never understood what a neural network is all about. We have just defined what these components can be, and we have superficially understood what these components are, but we have never completely understand. It's still a black box to the world today. Neural network
Yeah.
is still a black box which is just working fine for us. So now I just want you to answer this one question. Even if we run the program 100 times, let it be any number of times, we can't expect the same results back and forth. How is it that understanding that computer has been thrown with the same data and the same program at the end of the day, but it's still giving us an arbitrary results, which is not, which was never the same than what we had before? What is that all about?
Basically, when you say computation from the neural networks, I can say the best example in a simple way. Simple way, like if I want to say prepare some chai or something, I have all the ingredients. I know the process. I know how much amount I have to add, and I have made the tea. Right? If you ask me again, make the same tea in the same way, can I do that?
Yes,
It will
to one
change.
extent. To one extent.
Then one extent, yes, one extent. It cannot be same. If you're same, you are like a pro, right? See, basically, I mean, in anything, I mean, it's gaming or in the programming or in the studies. I mean, the person who really get highlighted is if he's consistent. If I'm achieving consistent in the first grade, he's like a pro, right? In the same way, even the neurons, when it's computing, it misses some information each and every time. Because of these changes, sometimes it may understand some part of the information, and the later when you're running the same thing, it may have grasped something else, and which will actually derives the model to give a different output, right? So these changes, it is not a random change. The change is always static, but it will definitely change. You have to know which seeding. Generally, in terms of we use seeding, basically the seeding defines the rate of change in the model's decision. Once we know the input structure or the shape of the data neurons, I mean how many neurons I'm giving input, how many dropouts I'm doing, we can calculate the random shape. So at what time it will change, and we need to give this recall the state like using the seeding, and we'll fix so that this won't become a problem for the production.
Yeah, you told about the production at the end of the day. It's the only thing we are looking forward to. There are ways in which production also has seen lot and lot of setbacks. TFX came in because of because TensorFlow had a little bit of glitch in the production level. Of course, it's very good when you are training it. It's hungry for learning. That's for sure. But I just want to ask you some questions where can there be an simulation of human vision and human speech one day in order to give that humaneness to the machines? Can we simulate it?
We can stimulate with the present way of the progress which we are making in terms of this field. It is definitely achievable, and the machines will process like a human brain using the main reason for the TFX to introduce is so many researchers which I mean, for example, I may have built a model which got at least 89% of accuracy, but when I went to the production, it is not capable of product uh, of implementing in the real world. That is because there are so many challenges in the production environment where it has to support the existing softwares, right? For example, if my database is SAP, from SAP, when I'm gathering the data, the model should communicate with the SAP to get the information and then push back the same data with the output to the SAP. And the communication between the models and the existing softwares, I mean, which they already been used in the industry. For example, the company may use SAP Labs, or they may use they ship from Google Cloud databases and all, right? So when the company have this already the structure on the top of it, when you're implementing any model, that model should uh, support the architecture of the existing application. So to support that kind of application, that's why that EFX came into play, which will generally integrate the models with the existing applications, and where it can communicate with each other and give the output, get the input and give the output. I mean, in TensorFlow, this part is missing when it comes to the production. When to deploy a model, it is much more difficult for us to sustain the state. When I'm saying sustain, that comes to the previous question. When it becomes the seeding, it won't give the same response, but even the data is same, right? That is what one of the major production issue, because I can't say uh, once if I take a photo of my face, sometimes it may say Sai Praveen, and sometimes if it says Vishwa, that change, right? So to standardize, to remove that from the production, it is a very different. One more thing will be like whenever I'm saying production, which is in live, which is a live project, whatever the data I may have trained will be have a good results, which will understand it. There can be so many scenarios, right, other than the data which I already have, where the data has not trained by the model. So for the data which it didn't got trained, how it will get respond, right? So always there should be a mechanism, which is we use a CI/CD, continuous integration, continuous deployment, where we see so many setbacks in the model's output. Then we will say, okay, the data which we train in the model is now it's outdated. We need to train with a new one, and again we try to learn with a new concept, new data distribution of the model, and then we will try, and then we will deploy that one and remove the previous version. So in this way, so it's always a learning process, because whatever the it's like correcting myself, right? So it is different from the other applications, MATLAB, or you can say Teams, or any application. Once installed, there is nothing like we can directly use it. There will be minor upgradation, beta version or alpha version in the apps where there's so many improvements and all. But in the case of AI, we should be very careful whether the data is par with the training which I already did. So there should be always a monitoring approach, so that the live projects will always be sustained and we will give a good result.
Yeah, uh, there are ways in which you have worked on self-driving car. That was your first when you were interning. I know that. I actually had lot of insights from what you said. Computer compilers and interpreters were different in those days. But now I just want to ask you this one question: self-driving car. What's your view on edge deployment of the compute engine that is going on? That's the new buzzword which is coming out in the industry. And also, what do you feel about the hardware architecture like von Neumann and Harvard? Should they really exist in order to give us that robustness in a computer architecture, or what is that new requirement that we are seeing today?
Yeah, when you say the edge AI, the edge computation and all, basically they support, as per my understanding, basically they support the multi communication with the devices, whatever we have. For example, if I have any phone, iPad, TV, if everything is controlled by a single processor in my system, in my home, if I send some information from one mobile to another mobile, the same communication should be reached through all the areas in a singular time, where I can connect all the devices which are related to my specific profile. So they are like my own specific devices, which are responding only to my own commands. If I say Alexa, do that, Google Maps, do this. So what is the time? What is the map? If I say from the, so the communication of the connection network with all my devices is what exactly Edge AI generally process to, because I'm not the only guy, right? There will be so many people, everyone has their own devices. So how they map a multiple level of communication with so many industry, so many clusters of the clusters, so many people at the same time. That kind of connection for these things is where Edge AI stands, because it won't take so much of time to uh, uh, receive or the to receive the data or to transmit the data from the both devices. So basically it is improving the speed, or it is decreasing the amount of information being lagged when we receive in the other device. It's edge computing. It is not going to the database. When, I mean, when I request some data, it should go back to the server, and it should query the data which related to my specific task, and then process it, and the result should be again driven back, should be thrown back to my device. So this is the response, right? So the amount of time it will take, for if I have the device, if I'm sending some photo, this image should be digitally transmitted from here to server. From server, it should update in the database. From the database, it gets stored. If I'm in the same time, if I'm asking the same photo in my another laptop, I'm going to download that image. So again, this should communicate to the database, then it should open it, and it should go to the specific location and then get downloaded. So this process time, right, it will decrease it by the edge computing, because the it won't need to directly connect to the database. So there will be specific in the front end, there will be a layer which will make that connection easy and possible, and decreases the computation time, and make the transmission very seamlessly and real time.
Yeah, there are FSD computers today which have AI in the boom. You know, uh, it's been deployed in Tesla, autopilot is there, everything is fine. But I want to ask something which is like very general for data science. The way in which we are data tagging, data cleansing, or else anything, data wrangling, whatever we have been seeing, right? Should there be an out of a layer where there is an redundancy where we are looking, because it's an redundancy at the end of the day. So now, all these, how are they influential in analyzing and giving the decision by a machine? How is it all about? You can give your own way of understanding of what can be the understanding of the machine in the future, and how is it impactful for writing a robust algorithm.
When we say the robust algorithm, which is defining cleansing and all, I mean, I basically, there is so much of research still going on. When I say, this is one of the tasks which is related to the fake news, right? I mean, this is one of the part which I'm working in Domina. When I say fake news, how we will identify whether a data is fake or not, right? For example, I should have some comparison table to say whether it is true or false. So these kind of problems, like I may have the data, I understood the text, understand what exactly is saying, what is it referring to, but I don't know whether it's true or false. It is similar, like for example, if you talk to some friends and or something, if they say, for example, I will come by 10 o'clock. If we say by 10:30, I will reach your home. What exactly I understand is, as per him, he will reach me at 10:30. But at 10:20, he may call me and say, bro, I'm not coming. So whether he's saying truth or false, right? That kind of comparison is not exactly there in NLP. It can only process the data. It can only understands it. It derives it. It responds back, but it cannot make whether a decision, whether any word or sentence is true or any word of sentence is false. If I tag them, these are the good things, these are the bad things, this belongs to a specific politicians, this is related to the sports. I mean, I can give the tagging myself, but I cannot specifically say this information is false or this information is correct, right? So these areas, because these areas comes into one type where is achieve, which is achievable, but as of now it is not achievable. The later one is when I say um, tagging, instead of tagging, cleansing, and all these things. When I'm cleansing the data, basically I'm removing the real data. Uh, I mean, as for me, to make my model work, I'm removing the data so that my work will be very smooth at the end of the day. But basically, the data which I already have is the real world data where I'm filtering out the information which may or may not be affecting my futures requirements, right? So I mean, still it is my goal where we should have a model without filtering any data, without any filters. We should understand the real world data where I don't need to cleanse it or I don't need to remove, I don't need to do these things and all, where it can process each single word and then derives a value. But if we can achieve that, where there is no filter or where I'm not losing any information to train my model, then my model will be able to give me a better response than the models which we are using now.
Now, how is it different from teaching a machine how to abstract or extract the actual information? And how isn't human intuition of understanding what the situation is? How are they different at the end of the day? Because we are on the verge of building AGI and we have not completely being successful because there is a factor of consciousness which is being involved in everything. You know, there's an truly an inspiration from Rig Veda which has already given out lot and lot of things also to the world, and also they are supposed to be built in order to answer the questions which human can never answer. Sometimes there are ways in which people have described it as it can give an explanation to the natural phenomenon which human can never understand. And what is it all about, according to you? That's what I really wanted to ask.
Yeah, for this thing, like I'm doing some research related to the Rig Veda, not exactly Rig Veda. Basically, I'm understanding how the brain works. Basically, like I mean, this is that in the question, how exactly the neural networks works, right? So when I say what is a, I mean, why it gets started? If you see how this actually started, is because humans understood our brain is the only thing which is processing the information. If I replicate my brain, so my workload will get reduced. That's the basic fundamental how these things came into machine. And instead of me doing a calculation with max how much amount I need to pay someone else, I can use a calculator or something else, so my work will made easy, right? So the basic level is how exactly the human brain works. I mean, in Rig Veda they already defined 6 types of ways any brain will understand the information. So it's like knowledge mining. So how the brain really understands, like when you see the newborn baby, how it actually is it how it exactly grabs the information of any language, of any emotions, the way they do the gestures. So basically it's like a new machine, right? It's a model which is ready, and with the environment, the way the parents who do, the way the teachers teach him, it tries to learn. So basically the 6 types of specific areas where the brains will understand upamana, upalabdhi, anupamana, anupalabdhi. You can go through my blog where exactly I define how exactly we can compare this to the specific one. One is specifically related to the information which is already existing. We can refer to I mean, we already have a data which is my past data. From the past data, I am making my decision. That is similarly ML and DL will come from. The other thing is uh, with the environment. With the environment, I will understand and I will deal with the decision. We can say these as self-learning autoencoders or something else, where it will automatically process, like in the recent in the past in the past when the India launched the robot to the moon, where the Mars, where the robot got struck, it self-refed. Reinforcement learning, with reinforcement learning, they understand itself and it moved out, right? So basically, with the environment, it will learn itself. That reinforcement learning is already a part of the brain, which generally humans being do. The other thing is the data which is all, it is not my data. I mean, my brain don't have that information, but some information is already getting passed through my DNA, right? The DNA information, where we can similarly say it as a transfer learning, where someone already trained the data, they already have the model. What I am doing is I'm just using the existing model and making some changes and delivering in my own ways, right? So we can say the transfer learning may be similar to the information which is already getting passed from our ancestors and then utilizing for our further improvement. And there are some other three where, I mean, these are the only three which we are still using and which we understand, and which we understand how to programmatically write these kind of things to make the machines to learn. There are another three types of ways where still we need to learn how to achieve them. I mean, that research is still in process, and I will definitely share the link in the comments, and where later you can go through and give your comments based on.
Last question I just wanted to ask you, because there are ways in which technology has been defined one way or the other. No, but what's that motivation that you have, and also what's the meaning of life according to you?
For me, the meaning of life is to learn and evolve myself every day. It's like I'm very tiniest part. When you say the cosmic universe, it's much more larger than my brain, which is very, very small, right? But even then, we are understanding so many things. So it is like everything. I mean, my only passion, or the only thing which I always like to do with my life, is to learn more and to be a better human and serve the humanity. This is why I also joined Omena as a community builder, where I do so many researches and we deploy models to support so many humanity problems like hunger, or for the sexual harassment, or where to for the climate conditional changes, how to track them, how to identify them. So where we are using the AI help for the climate, where there is a hurricane, whether there will hurricane in this specific location, or where we are getting the data from the real world satellite images, and then we are processing the data, and then we are identifying the task, and we're delivering the same thing. And there will be like when there is so much violence in Chicago itself, the FBI from the team joined us, and where we can identify where we can reduce these kind of information, because the only thing that is going on there because of wrong selling of the guns. So the guns are sold, get sold in online using some commands and an encoded language, which is not a specific language. They're doing some encodings, and then are doing some, they're delivering the deals here. So we use the NLP model to decode those kind of and language, and understands what location, where at what time the deal is going on, and where we will get informed. We will do the we will pass information to the police, and they will respond back to the extent. So it is like gaining the knowledge is always very, very important. Then utilizing the knowledge for the humanity is also a very critical part, which these two factors influences my life, and which always motivates me to do more work.
Thank you, Sai Praveen, for this amazing podcast. There are ways in which probably we are going to understand something more in the part two. I think part one is what we did. Sorry for asking you once again. There were a lot and lot of technical issues that I had faced in the first recording that we had, and you actually compiled all the things here. And thank you so much for giving such an wonderful podcast again in my podcast once again. And yeah, that recording and this recording will be online for sure, because I just have the exams now, so I should just need to stay away
Yeah,
from
yeah,
all the
fine.
editing and all. So part two will be for sure from my side. Thank you so much for it.
Yeah, thanks a lot, Vishwa. And always sanitize your hands, and be safe. Wear mask when you're going out, and uh, be very healthy and stay safe. Thank you.
Thank you.